Hey everyone, I wanted to quickly go over how to do a linear regression model in Excel. I'm using a data set that we've used before in class where we were attempting to predict the earnings of graduates from a range of different MIS programs around the country. And we were predicting those earnings using the tuition cost, the graduation rate, the percentage of students graduating with debt, and whether or not that college was located in a city. So we have three questions we also want to go about answering with this model. Our first question is whether the number of students graduating with debt has a positive or negative relationship with earnings. Will you earn more money if you attend a college in a city? And if I have an MIS degree from Chapman University, how much money can I expect to make after graduation? So before we can answer those questions, we need to build a model. And we have a couple of hints of what we're trying to predict with this model. In each of the three questions, we focus on the issue of money. So does the percentage of students graduating with debt positively or negatively relate to earnings? Will I earn more money if I attend college in a city? How much money can I expect to make after graduation with an MIS degree from Chapman University? That's going to be our dependent variable, or our Y variable. And our biggest hint is that it's the topic that we're consistently being asked about. So we're going to build a model, and we're going to predict earnings after graduation using the cost, grad, debt, and city independent variables. To do this, we're going to go to Data, Data Analysis, and then we're going to go down to Regression. If you don't have that Data Analysis button popping up in Excel, you can go to File, Options, and then you can manage your add-ins there. So here I've opened up the dialog box for Regression, and the first thing I'm going to do is I'm going to input my Y range. So this is my dependent variable. In this case, I have it here in column C. And I'm going to just drag that down and include all 115 observations. And now I'm going to do the same thing with my X range. All four of my independent variables are neatly next to each other, which is actually a requirement in Excel. One of the reasons why I generally like using R for this type of work is that my data doesn't have to be organized in a very specific way. But in Excel, all of your independent variables must be next to each other, so you can select it as a rectangular shape. In this case, I've also included the first row, which are labels. So I want to make sure my labels box here is checked. And then I want to see the output on this page, so I'm going to click Output Range here. And we'll have the output start in cell I12, or we'll do I11. Looks like I accidentally messed with my input Y range. That's not a problem. I can just go back and select it again. So now I have my input Y range is correct. My input X range is all my independent variables. They're all selected. I've got my labels. I have my output range. Let's run this thing. Now I scroll back up here and I have the summary output for my model. So the first question we're trying to answer here is, does the number of students graduating with debt have a positive or negative relationship with earnings? So that would be our debt variable here, and just highlight it to make it easier to see. And we see that debt has a coefficient of 142.549. So that is a positive relationship with earnings, suggesting that with each increment of debt, students would earn another $142.50. So we see this relationship as positive. On the other hand, we can go over here and evaluate the p-value for the t-test of this variable, and we find that it is not statistically significant. So on one hand, having more students with debt does seem to have a positive relationship with earnings. Doesn't appear to be particularly significant. So Yes, but not significantly. Our next question, will I earn more money if I attend college in a city? So for this problem, we can look at our city variable, and I'll highlight it here. We'll go with orange. So here again, I want to interpret my coefficient for city, and I want to evaluate the p-value, the test of significance. And in this case, we see that we have a coefficient of 2,553.437. So that's a positive relationship, and this suggests that if you attend college in a city, there is a premium of about $2,500 in terms of your earnings. And we do find by evaluating the p-value that this is actually pretty significant if we're assuming alpha of 0.05. So we're 95% confident or better that this positive relationship is significant. So that's interesting to note. Our last question is, how much money can I expect to make after graduation with an MIS degree from Chapman University? I'm kind of partial to Chapman University because I lived in Orange, California when I was growing up, and it's a cool place to live. I'm going to highlight its data there in blue so it's easier to see. So the actual earnings are $51,800. We'll see how close our model gets to actually producing that value, given that it has an annual tuition cost of $33,821, 74% graduation rate, and 87% of students graduate with debt, and that it is located in a city. Orange is a nice place that is sort of in the suburbs of Los Angeles. So to calculate how much money I can expect to make after graduation with an MIS degree from Chapman University, I'm going to use my coefficients. So my coefficients, which I'll highlight in blue now just so you can see them, I'm going to multiply these coefficients by the values I have for my independent variables. So I'm going to type out the equation in this cell. I'm going to start with an equal sign. I'm going to go to J27 is my intercept. I don't multiply my intercept by anything. And to that, I will add J28 multiplied by D13. So here I'm multiplying my coefficient for cost by the tuition cost that is given to me. And now we'll work our way down to the graduation rate. So that's J29, which is highlighted in green now. And that will be multiplied by E13, which is our graduation rate from Chapman University, 74%. On to J30, which is the percentage of students graduating with debt. I will multiply that by 87, or F13. And then finally, I'm going to add in the coefficient for city, J31, and I'm going to multiply that by G13, which is whether or not the school is located in a city. Now I'm going to press enter and we're going to calculate it out. So the model is predicting that I can expect to make about $52,733 upon graduation with my MIS degree from Chapman University. So the model is actually predicting a slightly higher earnings than the actual data shows, but actually it's within about $1,000, and that's pretty darn close. That's pretty good. So this was just a quick spin through how we can put together a linear regression model in Excel and how we can use the results of that linear regression model to answer real live questions. So I hope you found that helpful. Let me know how it goes.